Okay, we are still finding inverses. When it comes to 2 by 2 inverses, I'm still going to be honest with you and tell you that my preference is to you do it using the way we just went over yesterday and had our homework quiz on. So 2 by 2, I still like the other way. I just think it's faster and easier. But we have to kind of learn this row operations method. We have to learn it because when it comes to like a 3 by 3 or a 4 by 4, you have to do it this other way. And so I'm starting with a 2 by 2 example just so you can kind of wrap your head around the process with a simpler example. So, when we're trying to use this row operations thing, we're essentially going to try to turn this into the identity matrix. So what you'll see people do a lot of the times is they'll put like a dotted line there, and they'll put the identity matrix next to it.
Hold up. Come on now.
Excuse me while I step on your...
Why would you push that away? A robot comes through your door?
Yeah, like...
This is... I gotta get in the zone because I haven't done this in a lot of years, so I gotta like think myself. Okay, so we're gonna try to turn this into this, and there's a couple things that you're allowed to do. You are allowed to multiply rows by things. So I'm gonna put over here what you're allowed to do. You're allowed to multiply rows. You're allowed to kind of multiply and add rows together. And you're also allowed to swap rows. And so those are really the three things. If I come up with something else, I think those are the only three things we're really allowed to do to let this left-hand side turn into the identity. So we want a 1 here, a 0 here, a 0 here, and a 1 here. But you're never going to do it all at once. It's going to be like a 3, 4, maybe 5-step process. So I like to just start in the upper left-hand corner and get this to be a 1. So if I want this to be a 1, I can just multiply this entire row by what? -1. So here's what I also think is very helpful because this can get confusing. I think it's really important that you write down what you're doing. So I'm taking row 1, which I'm going to use a subscript for the row 1. I'm going to take row 1 and multiply it by -1, and that's going to become my new row 1. So down below, I'll do that. I left a whole sheet of paper because I suggest we use as much space as we need to keep this clear. So if I take row 1 and just multiply everything by -1, that's going to be 1, 2, there's my dotted line again, -1, and 0. And I'm not touching the second row. So far, so good. That's step 1. Keeping your eye on the fact that we want to turn this into an identity matrix. I usually go down first, and I try to make this a 0. So you can't subtract 3 from everything. That's not an option. You can multiply rows, you can multiply and add rows together, or you can swap rows. But I can't just subtract 3. It's not an option. So what I'm going to do is I'm going to take row 1, I'm going to multiply it by 3, and then I'm going to do row 2 minus that. Does that make sense? So I'm going to take row 2, because I need, when I add or subtract the rows, I need this to become a 0. So in order for this to become a 0, I do have to subtract a 3, but I can't just subtract a number. I have to subtract or add a row times the number. So I'm going to subtract 3 times row 1. And that's going to become, and here's what I think is the most important point, that's going to become my new row 2. I'm taking row 2 and I'm going to subtract 3 times row 1. So when I go to write this down, I'm updating row 2 which means row 1 is going to be exactly the same. I did. 3 times row 1. I'm going to start with row 2, which is 3. And I'm going to subtract 3 times this. Because my goal right now and what I'm trying to focus on doing is changing this to a 0. So I'm replacing row 2 by following these steps. I'm trying to think about where. I am multiplying row 1 by 3 so that when I subtract it from row 2, it becomes something else. Row 2 becomes something else, which is why I keep saying this is the most important, is what is your goal to change here? My first goal was to change row 1, and I was changing this to a 1, so I just multiplied it, and that replaced my row 1. When I'm doing this, my goal is to get this as 0. So when I do this, I'm changing row 2 using this algorithm, or just rule, okay? So row 2 is 3, minus 3 times this. What is 3 times 1? 3. So 3 minus 3 will make that the 0 that I wanted. And then everything else is just going to naturally become whatever it becomes.
So you'll change row 1.
Correct. We're using row 1, but it's all in an effort to change row 2 in this particular step. Okay. More examples you'll see. So now if I go to my next term, because I have to rewrite all of row 2, I'm taking that 4, which is in row 2, and I'm subtracting 3 times this, which is 6. So 4 minus 6 is negative 2. I keep going through the whole bottom to get there. So row 2 would be 0. Minus 3 times this. What's 3 times this? Negative 3. So minus negative 3 makes it plus 3, right? So 0 plus 3 is 3. And then row 2 here, which is 1, minus 3 times this is just going to stay 1. Right? Because 3 times 0 is 0, so 1 minus 0 is 0. So by the way, as this becomes my identity matrix on the left, once this side is my perfect identity matrix, this is going to be my inverse matrix on this side. So they're kind of going to flop. That's kind of where we're headed. So like I said, I like to kind of work down and over. So I'm going to get this to be a 1 next. Follow? So what could I do? I'll let you guys be creative here. What can I do to make this become a 1? Just divide it by negative 2. Or multiplying it by negative 1/2, same thing. And actually, for whatever reason, if you were to watch like an online video on this, usually they don't like divide rows by things. They'll multiply it by the fraction instead, but it's the same thing, so I don't really care. I'm just going to say we're taking row 2, and we're going to divide it by negative 2, and that's going to become our new row 2. So, and that's why I get the 0 to be a 0 first, because then when you multiply it by something or divide it by something, it's still going to be 0, which is what we wanted. So when I rewrite row 1, change nothing. And when I rewrite row 2, I'm just dividing every term by negative 2. So I get 0, 1, this is ugly, negative 3/2, and negative 1/2. And we're one step away. What can we do to row 1 to get this 2 to become a 0? Okay, so here's like a good general rule that I actually just kind of thought of in summary. If you're trying to get things to become zeros, that's when you kind of have to use multipliers and add rows together. Because if you just multiplied by 0, you're going to change everything to a 0, and you're going to screw up the fact that we already successfully made that a 1. And you don't want to do that. If you're trying to get a number to become a 1, it is really easy just to divide by that number. That part's easy. So becoming a 1 is an easy step. When we're trying to make a 0 happen, that's what's going to be a little bit trickier. We essentially want to subtract 2 from this somehow. But again, you can't just subtract whatever old number you feel like. You have to subtract another row or add another row that's been multiplied by something if necessary. So because that's a 1, I can just take this number and I can subtract 2 times this number and it will become a 0, right? That makes sense? So essentially I'm taking row 1 and I'm subtracting 2 times row 2, and that's going to give me my new row 1. And so because this is a 0, you're going to see that's not going to be affected over here. This will stay a 1 and this will stay a 0. Your row 1 is what's changing, so I'm going to leave my row 2 the same. And so to get each of my row 1 items, I'm going to take row 1, which is 1, and subtract 2 times 0. And that's why I work down first. So to get those zeros, now I haven't affected the 1, right? Because 1 minus 2 times 0 is still 1. And I don't want to mess that up once I've achieved that. Allie?
How are we supposed to figure out, like, how to multiply and add rows?
You just have to focus on what am I trying to change, and how can and there might be another row at some point, how can one of the other rows help me get this 2 down to a 0? So the only way to get this 2 down to a 0 is to subtract 2, unfortunately. And so there's not another row that's another 2 already that I can just say, hey, okay, subtract row 1 minus row 2 and I'll get there, because I don't have a 2 anywhere else in that row. So I have to use a multiplier to make that 1 a 2 first, and then I can subtract it. Okay? So on this next one, I'm taking row 1, which is a 2, and I'm subtracting 2 times this. 2 times this is 2, and 2 minus 2 is 0. So I got the 0 that I wanted. On the next one, it was a negative 1. That's my R1. I'm subtracting 2 times this. Luckily, that's pretty easy. Right, because the denominator is a 2. So 2 times this fraction is just going to be minus 3. So it's negative 1 minus a negative 3, which is negative 1 plus 3, which is 2. I can tell you definitely don't want to rush through your arithmetic because it will throw you. And then the last one, 0 minus 2 times negative 1/2. If you guys want to write that out, you're more than welcome to. 0 minus 2 times negative 1/2. That definitely might help. Just less thinking, more writing. It's a trade-off. You have to do more physical labor, but you don't have to do as much mental labor. So you're usually going to be a little bit better off if you do that. So that's just going to become 0 plus 1, which is 1. So now that we've achieved the identity over here, this is our inverse matrix. A inverse is this right here. Now, I started with this easy one for 2 reasons. Number one, it's a tough concept to wrap your head around, so I figure starting with a 2 by 2 is easier than anything bigger. Also, we know the alternative way of finding an inverse. We just learned yesterday that to get the inverse, we do 1 over the determinant, which is negative 4 minus negative 6, negative 4 plus 6, right? Negative 4 plus 6 is 2. And then we flip-flop stuff. So negative 1 and 4 switch, and negative 2, 3 get negated. And then when you distribute that 1/2, you get 2, 1, negative 3/2, negative 1/2. And that's what we got. Okay?
So much more complicated.
I started by telling you why I had to do this. Why was it? And I also started by telling you, if it's a 2 by 2 matrix, I prefer this method. I'm going to do this and memorize that way every time. The problem is, on 3 by 3 matrices, that whole thing doesn't work. There is no shortcut. On a 4 by 4 matrix, there is no shortcut.
There's no other way to
to do the upper level ones. I take that back. There are rules. They're very complicated though. And so, yeah, we don't want to, it's just going to be a slow, you have 3 of these tonight for homework. No, it won't. That was your first one. You guys are, well, that's because I'm explaining, so I'm going really slowly. As you do more, you will get better off. So, all right, here we go. You guys are funny. All right. I don't know if I like to do this because it's the only way to do this, or if it's just easier for me. But I'm going to teach you what I find the easiest because I'll just assume it is the easiest for you. I start in the upper left corner. I need to get that to be a 1. Yes? What do I do to the top row? Actually, it's on the back. Oh, Ellie, you had to pick up this thing on your way in. Because that little space in the bottom of your notes yesterday was not enough room. Were you trying to cram all that in there?
Oh, yeah.
So, just take this and well, now it'll be clear for you anyway. And then on the back, you can do the back. You have to be kidding me. No wonder you 3 were stressed out. You were trying to cram all that in at a 2-inch by 2-inch space. I'm all about...
Anyone didn't pick it up.
All right.
I never pick up the show. It's like this one.
Okay. So I'm going to first get the identity matrix next to this, which a 3 by 3 is obviously slightly different. You just have 1s across your diagonal though. So in that respect, it's the same. So first goal, top left corner. Get that to be a 1. Now, I could just divide everything by 2. Yes? One method, though, that I told you you could use that we haven't yet used yet is you can just swap rows. So if the second row is already starting with a 1, I can just bring that up. So I'm actually just going to swap row 1 and row 2. That's just why that's better. I don't have to deal with a fraction. Okay? And by the way, it's worth telling you now, there's multiple ways to do the same problem. There can be. Like some people might decide to divide everything by 2, especially if that 3 was a 4 or something and it could divide nicely. It really wouldn't matter, but it will make the look of 2 different people's very different. They should still end up at the same spot though. So just keep that in mind. But I'm just going to swap here because I don't like fractions. And make sure you're swapping right through that identity matrix too. Okay, so that mission is accomplished. So now I like to work down here and get this to be a 0. Getting things to be a 0 is like taking it, that's like the little bit harder way. But if I look at that and I want that to be a 0, I should look at other things in the same column. And how could I get that to be a 0? I could take row 2 and subtract double this one. I could. Or, if I want to get the multiplier completely out of that, what else can I do? I can just do row 2 minus row 3. Because they're both already 2's and I don't have to use a multiplier. So if I take row 2 and I subtract row 3, that's going to be my new row 2. So row 1 is exactly the same. And 2 minus 2 is 0. 3 minus 0 is 3. 0 minus negative 1 is 1. 1 minus 0 is 1. 0 minus 0 is 0. 0 minus 1 is negative 1. I just took row 2 minus row 3, and that's my new row 2. And row 3 stays the same. I really, really think this is critically important, is that you always keep track of what am I replacing. Yes, I'm using row 3 to do something to row 2, but the goal on that step was to change row 2 only. Now, I don't know if it really matters here. I could jump on trying to get this to be a 1 next, or I could go down and keep getting these all to be zeroed out. I don't think it really matters. So let's just focus on replacing row 3. How can I get this to, do you have a question? Yeah.
There's a switching, yeah.
Yeah, you're switching, so how do you know which one to change?
So when I start, I'm looking at the original problem. I decided I wanted to get this a 1. I did what I needed to do, and I don't ever look at that again.
So it's that one.
So now I focus on this one. How did I want to get this to be a 0 using this matrix?
Yeah, then it switches every time.
Everything switches every time because this side is slowly morphing into our inverse. When you say it is switching every time, what is it?
Like the ones and the zeros and the
And that's what they're supposed to be doing because it's slowly, every move is slowly morphing this into our inverse matrix, which is what we're trying to find.
So what are you going to try to do?
So our goal is to slowly manipulate the left to turn it into the identity matrix, and whatever happens over here, and this side will become our inverse matrix, which is what we're looking for.
But then you said like you want to get 2.
Yeah. We can. So I got that to be a 1. I got that to be a 0. I'm moving here. What can I do to this row 3 to come up with a new row 3 where this is going to be a 0? I'm going to take this number, which is row 3, and I'm going to subtract 2 times this, which is row 1. And if I take 2 and I subtract 2 times 1, that gives me the 0 that I want. And that's going to replace my row 3. And this is where I think a lot of you might benefit from term by term showing your work. So I'm going to keep row 1 and row 2 identical. And then here's where I think you guys would benefit from showing a little bit of work. So your row 3 number, and we're just doing the first spot, is 2 minus 2 times my row 1 number there. And what is that? 0. So that fills your bottom left. Move to the next spot. My row 3 number, so R3 in this spot is 0 minus 2 times the row 1 number in that second column is negative 2, and so that all would become positive 4. Next spot, row 3 number is negative 1 minus 2 times the row 1 number, which is negative 1 there. This is where doing it in your head would get confusing, right? Negative 1 minus 2 times negative 1. If you see it, hopefully you see negative 1 plus 2, and negative 1 plus 2 is 1. We keep going. Row 3, 0, minus 2 times row 1. 0 minus 0 is still 0. Next spot, row 3 is 0, minus 2 times row 1, which was 1. What's that give you? Negative 2. And the last one, row 3, 1, minus 2 times the row 1 of 0. 1 minus 0 is 1.
How do you know you're done?
I'm not done. Oh, I'm not done. I'm not done.
There's 2 minutes left.
Oh, man.
How is this doing
We're gonna die.
I'm not doing the homework tonight.
I didn't realize we only had 2 minutes left. Well, guess what? We can go at whatever pace we need, so I'm good with this. So, for the record, these are your 3 homework questions. How about you just do 19 and 20? Reason being, they're ridiculously easy because your zeros are all already filled. You just need to change into ones, ones, and ones, which will be, this will take you all of 3 minutes, probably.
I just
No chance.
Ellie, I'll help you. Divide that by 2, that by 4, and that by 6, and your answer will be there. Divide by 3, divide by 6, divide by 9, you'll be done. So just put these next to the identity matrix and do those divisors, and you'll be done. Your homework is on the bottom of last night's. Oh, man.
You should just send a picture of this.
That's silly. I'm just going to hand these back. Mike, I mean, if you want, I'll go.
Can I just take a picture? I'm just taking a picture.
Oh, sure. I don't care. Take pictures for me. You want to just take a picture of the
No,
board?
I want my picture.
If you want, okay, for that. Anybody else want the paper bag? What were you saying?
Oh, I've almost hit a bunch of bikers on cars.
You have?
No. Only in the morning because it's